The series which I've started is called as certification preparation, or so called as interview preparation. So the preparation would be very similar, because like whenever you attend interviews with cloud architect, or people want with anything with related to DevOps roles or anything, they would be mostly likely to look about uh, your experience in architecting solutions, or at least you should know all of the well-known services. Okay, so why it is important, we have discussed in the cloud attributes as well, right? Cloud computing attributes, so which basically says, like you need to put up your solutions or thoughts around those particular five attributes in order to succeed or make a good solution on cloud, okay, for the customers. So the similar things, we're gonna have something discussion across. What I can say is, what's better if you know about the services what you're gonna consume. Okay, so what I would suggest is, let's go through something called as, let's have a brief comparison between what are the services which are given by various public vendors, like Amazon, GCP, the offering from a cloud offering from Google, and Azure, a offering from Microsoft, and AWS, a cloud offering from Amazon itself. So we will take up all of these public vendors. We'll try to differentiate each of the public vendors on various services or products they have to offer to us. The main thing what I want to say is, like at the end of the day, these would focus more around the compute, the networking, and the data or the storage part. Okay, so these are the only three basic fundamentals which you need to know. And like whenever you build applications or write applications or system design any of these applications, they would go across this. Yeah, the basic offerings with compute, storage, and network is given by all of these public vendors, but the only difference what I say is, the sort of modernization which they have done in their respective areas are very different. Okay, so take up an example of serverless computing. So okay, serverless computing is offered at very less price from GCP. Okay, and the price concerns are different, but the technology which they have advanced or they have written on top of this compute storage network will make the difference in the market. Okay, so because as a developer, we don't want to go and manage a complete infrastructure before actually deploying my project or making my web application live or host my web application, right? I won't be interested. So what I would do is, just list out these all the categories of applications which I have listed it out already for you, and we will just go through and we'll discuss about it. Okay, so this is just a banner which I took from Quora. So it says about AWS, Azure, and Google. Okay, and these are to make familiar with the icons which are there on with these public vendors. Okay, so these are the offerings which have been categorized upon compute services, storage services, machine learning, strengths, and the weaknesses. Okay, before that, we would try to take you to something called as the list, which I have figured it out, and I made it as part of this certification or interview preparation. Okay, so mostly, like since we talk about compute, storage, and network, uh, uh, the compute, storage, and network, so let's start with IaaS. IaaS is nothing but IaaS, or so called as infrastructure as a code. Okay, infrastructure as a service, sorry. So what happens is, like, you take infrastructure and you give or rent it out for people. Okay, so it's a service. So you're taking your infrastructure or a box. Take an example, like you have a desktop or a laptop and you want to give a rental to someone. So this is very equivalent to that, but the scale which we are talking about is very higher. Okay, so let's start with IaaS. So infrastructure as a service says, like in Amazon, the offering is called as EC2. It's sort of a box, you can say it as a desktop or laptop, which has been kept on a rack, on a server rack, and it just been given to customers over intelligent OS, like the so these are particular EC2 instances, or what I can say is Azure virtual machines or Google Compute Engine. So these are the offerings from these various vendors. Okay, Amazon calls it EC2, and Azure calls it virtual machines, and Google call it as a compute engine. But basically, what happens? These all particular virtual machines would the simple, like you take a rack, server rack. Server rack consists of nodes. Nodes are nothing but you stack all of your laptops serially and attach them serially. In fact, in RAID configuration, and then it can take it can take the that particular capacity of. So if you have a single laptop which is of 6 GB RAM, and then in fact 8 GB RAM, and the database of like you can see the memory of the secondary memory of around like 200 or 250 GB, then if you connect both of the laptops together serially in RAID fashion, then it would be like 250 plus 250 is 500, and around 8 that is the memory. And and the network, it will have a different IPs as well, and on top of that you will increase the RAM by 18 GB, like around 12 GB of RAM. Okay, so that's how the whole data center is done. So they have all of the nodes on a single rack, and they have something called as top of TOR switch or top of rack switch, from where this all the all of the traffic which comes inside and goes out need to go and come throughout this TOR switch. So on top of the TOR switch, we have a lot of load balancers and load balancers and regional traffic managers, and then we have traffic managers which take care of load leveling this particular traffic which can come to this particular laptop or the rack. And when customer clicks and try to provision a resource, he will get connected to this particular node which is in the server node. So whether this particular customer is sitting in India or is sitting in US or somewhere, he will be get connected. So that's what is a particular virtual machine or a box, I can say, where he will be able to remote into that particular desktop or the EC2 instance or compute engine, and he's responsible for maintaining the patches. Okay, so that is what is infrastructure as a service, and these are the offerings from the various vendors. And if you take a look of platform as a service, or so called as a PaaS, and we have something called as AWS Elastic Beanstalk. So Beanstalk, I would like to like I would describe about the Beanstalk in brief in the upcoming videos. And in Azure, it's called as Azure App Service or Cloud Service. So Cloud Services, it's been there from the classical time, when in the year from 2012 2011, and at that particular time also we had Cloud Services, and then slowly in 2014 we got App Service, Azure App Service. So what is the main difference is, like, it's the same, like it's like a box which we talked about in IaaS. So it's a box, same box, but this box will have logical isolations underneath it, and all the customers can spin their own particular applications inside this particular the logical boundary. Okay, so that's what is cloud services and app services. They work this way, so where they share the resources, or they share the storage, compute, and the network with the other particular users. Okay, so when you go to Azure or any of this particular vendor, when you spin up this resource over Beanstalk or cloud service or app engine, your resources are shared. That's why you do not need to worry about the cost, because they are less from that from the infrastructure as a service. And also the patch, everything would be taken care by the patches, everything would be taken care by the public vendor itself. Okay, so that's one thing, that's PaaS. And if you go about more about functions, which is called as, functions are nothing but serverless computing. So serverless computing, how exactly it work is like, you have similarly, so similarly you have a node, but again this is more abstracted than any of the IaaS services or PaaS services. What you have is, like, you can just like there's a robot side by me, right? So you just command the robot and say that you go and fetch from this particular table, that rocket is there. Okay, fetch that particular rocket. It's the same thing, similar thing. You just give the job to any of the public vendors, by using anything called as, Amazon Lambda, the Azure functions or cloud functions in Google. So you just give them, or set a recursive, or trigger an event based, like event based triggering everything. you just give the command like what you need to execute. So at that particular time at runtime, your request will go and get executed, and then it will ping back you the results. Okay, so ping back the logs, everything what it has executed, everything. So it's like, at runtime you are executing your job or processing your job. Okay, you just have a code. And because basically this serverless computing, you just need to write a code. Either it can be a PowerShell, or it can be a C# or Java or Python or Ruby, or any particular code. You mention these things that you need to execute this set of jobs, and you trigger your job. Okay, and then it would be the Azure function or Lambda or Azure function, the cloud functions responsibility to go and execute this job on a box and get out the result to you. So this is very good because it's even cheaper from the if you compare with IaaS or PaaS, even from the PaaS services. And the basically the charging is based upon what I can say is like the number of transactions or number of jobs you execute. That's even good because for startups and for companies who do not want to spend much, it's a very good option. Instead of going and getting a complete box, a new box, and keeping it at your home, you can actually go just and use the same just have a partial computing power and then use it. And then if you go next, then we have something called as DNS. So DNS is the domain name resolution services or DNS services. So when we talk about DNS, it's basically a domain name resolution which resolution services, which actually works in a fascinating way. Till now we had very centralized vendors for that. We didn't had any public vendors approaching into it. The DNS services were only, if you take an example of the DNS services which is given from GoDaddy and other persons, obviously they have a third-party integration where you have just, like if you want to host a website like the azureguy.com or something, you just go to them, you say that I want to host this particular and host this particular DNS service in your particular the area. Then you just go get the domain first, and then you make this entry, you give this entry of your .com website to them, and then you add a CNAME to it. The CNAME would be specifically your own IP addresses where you are exactly running your website. Okay, so that's how when people would type www.theazureguy.com, they would redirect back to the CNAME or the IP which we have given. Whether this particular CNAME or the IP which is hosted either in Google or GCP, in Amazon or in AWS or in Azure itself, so it do not matter. The only thing, the DNS would matter. So the same thing. So these public vendors also have their own DNS entries, so the DNS offerings, even I can say. So the first one is Amazon Route 53, and then we have Azure DNS, and we have Cloud DNS from Google. And if you go a little bit more onto the virtual network, so the virtual network is nothing but it's sort of abstracting or provisioning your resources under a subnet. Subnet is again what I can say is a logical boundary, network logical boundary, where you can keep it in your own environment or in your own domain. Okay, you do not want to take this particular the subnets or VNets. You can mention the VNet or subnet in your on-premise, or you can use from your own on-premise, or you can actually provision on these public vendors. Okay, so when you provision this particular VNets on the public vendors, so they have certain namings like Amazon call it as a virtual private cloud, and Azure as Azure VNet, and Google has something called as virtual private cloud. And then if you move forward, then so if I want to speak a little bit about virtual networks, then nothing but like each of if you want uh, make available a laptop which you are currently running to your firm, then you all need to keep that particular laptop in a work group, right, in a workplace. So how the workplace is created, workplace or work group can be created, work group in the sense, so laptops can talk to each other. Okay, right. So they can actually access service which is hosted in another laptop, like that. So it can be done because they are part of the same work group. Okay, so in order to make this the possible, at the network or the hardware level, what you do is like you put your IPs or your machine IPs tag the IPs which are in the subnet to your machine IPs, and that's how you can keep in a single range. So when it comes in a single range, they can be able to talk to each other. So that's what the subnet. And when you include these particular subnets across a various a bigger logical grouping, that would call as a VNet. Okay, and VNet has a very like on VNets you can mention NSGs, you can set something called as network policies, so that you actually can control the traffic, who makes a call, or the ingress and the egress traffic, everything will control with that. And going forward, let's go to storage. And then in storage we have interesting, because storage are there are a lot many types we're going to talk about in storage. So one particular, if you just pick up a storage term, we can talk about Amazon, which has offering called as Elastic Block Store, and in Azure it's called as Azure Storage. So these are sort of NoSQL combination only, but as you see, the Azure Storage, it has also an offering of Blob Storage, okay, where you can store non-relational or different sets of data. It can be your videos, it can be video files, or it can be your audio files, it can be images, or it can be any amount of the HD data. You just can stream in any type of data inside this particular Blob Storage. Okay, and they have a few of the vendors, they have offering of hot and cool, where you can mention like if you have more read access, more read write work which you're gonna do on this particular storages, then you can mention it as a hot account. And you can also mention it as a cool account if you are using that particular account or storage for sort of archival, like you just want to store your artifacts or any particular files in there, and you're gonna retrieve rarely, like once in a month or like that. So that would be sort of cool storage account. And then we go to database. So database is database. When we say we're going to talk about relational databases only. So relational databases are, one particular example I can say is SQL, MySQL. These are all relational databases, because you have the keys concept, the primary key, the secondary key concepts, and then you use a mapping and other particular technologies, or what I can say is mechanisms to retrieve a data. Okay, so one particular example from Amazon is RDS. They call it as Relational Data Services, Database Services. And then we have on Azure is SQL database. So SQL database is an offering. So this SQL database offering is also there as a database, like it's there as a IaaS offering, and it can also be get as a PaaS services, because we have Azure SQL database services as as a service, where you just do not need to maintain the machine which is on which the SQL database is running, okay, or SQL server is running. You just utilize whatever the data you want, and it's also scalable. You can share this particular SQL databases, everything. It's very similar to the other vendors as well. So Google call it as Cloud SQL, Amazon called it at RDS. So these are almost all of the facilities, the shading, everything is available with all of the public vendors. There is no restrictions. And if you go forward, and let's concentrate upon the NoSQL data store. So NoSQL data store is very different from the relational database systems, where you do not have relation between the tables, and you don't have limitations of adding columns. Like if you take an example of RDS or any relational database, then if you have a table which has a columns, and you want to add another column, then in that particular RDS cases, it's as of my knowledge, so it like you need to drop that particular table, and then add a new column, create a new table with the new column, and then start entering the data. But with NoSQL, it's very flexible. You do not need to worry about adding any number of columns at any point of time. You create with a single column table, and you can start ending up with 10 or 12, maybe thousands of columns in it. Okay, there is no restrictions. You can expand the columns at any point of time. And the NoSQL being cheaper, and they are, yes, obviously there would be a little latencies compared to any of the relational database, or what I can say is gathering of data. Okay, so for NoSQL you need to specifically take precautions, or what I can say, your code must be well optimized to read and write data. Okay, you can't actually go and just have a key mapping, and then your data will be retrieved, because in relational there's a lot other things, store procs and other things are there which actually take care of your particular queries, which you do and in front. Okay, but in NoSQL there is no concept of store procs or any other particular concepts, which doesn't so the mechanisms will not help you in making your data retrieval faster. So you need to write your code so properly, so that you get your data with less latency. And then okay, so if we talk about NoSQL data store, we have DynamoDB in Amazon, and then in Azure we have DocumentDB, we have Redis, we have SD Insights, and each of these particular different data stores are used for different sort of workloads. Okay, SD Insights are mostly used with big data computation. And if we take example of Google Cloud, so or GCP, they have something called as Bigtable, Firestore, and Spanner. We will go through about all these services later, but yeah, let's go with the pricing comparison. So you can see that we have gone through a lot of most of the highlighted services, which are very very much used, I can say, in day-to-day life. So I've made a brief description on this particular services, what they call in a different public vendors, so that it would be easy for you to prepare for your interview. Okay, so you saw that the rate of innovations which is going in there with all of this public vendor, it's a huge competition. The competition is not only on the technology R&D, the competition is also on the pricing point. So because at the end of the day, the users or the enterprise would only go if the prices are less with any of the public vendor and they are more reliable. Okay, and the pricing with Microsoft, Azure, and AWS, they're always competitive. It's because if you take an example of B2S image in AWS, in Azure and AWS, there is a difference of $1 per hour, like $1 per day. It's a tough competition between them. Either if one of the services is lesser than the other services has a good other margin. Okay, so if virtual machines are less in here in Azure and AWS, then it's more in Azure, like that. Okay, it's like a bit tough competition to say like which one is cheaper, because they have very competitive rates in here. And then if you take example of GCP is also very competitive in other offerings. But one particular offerings I would talk about is it's the best or the cheaper solution for all serverless computing. Like if you're running a cloud function, then probably that's a cheaper cloud function, or any serverless computing. Like instead of using Azure Functions or Lambda, I would suggest use Cloud Function, that because that's going to be a cheaper option for you. So that is what is comparisons of these all three services. And I will be adding this particular link if you want to. I just found it something relevant, so that you can use them. Okay, so let's talk about the machine learning, how these vendors are doing with respect to machine learning. You can see most of the many of the services are there, like offerings are there from AWS, like called as SageMaker, AML, and some other offering. TensorFlow is one which I've heard very well, and Azure has just one offering called as machine learning. It actually gives algorithms as a service, I can say. Like it optimizes the algorithm, and it just makes it more simpler to for the developers to just use it and get get that particular all the analysis, and then boom. And with cloud they have also with Google Cloud they have also something called as cloud machine learning engine. And if you go on to the strengths and weaknesses of this, and yes, so the AWS being like 10 plus years old in the market, it's very dominant, and it has made it position like that. And Azure started bit late than GCP, 2 years later than GCP, but it actually is the second largest provider right now. And Google is pacing up with these guys, and they are designing cloud native businesses as well. And AWS is extensive, and they have a mature offerings. Whatever services they give, they have very mature and very well tested offerings till now. And then And then with AWS, you have good support for large organizations, good enterprise support as well. There is no issues like, it came late, but the support won't be good as Microsoft, but yeah, it has a good support for AWS services. And extensive training, yes, I would go. They also host something called as AWS Summit and other particular events like Microsoft. They conduct something called as MS Ignite, a build event which is right now going on. And then build 2020 is going on. You can go and tweet, or go to Twitter and try to search and take a peek onto what innovations are actually going around in Azure. And then like the global reach is like, what I can say is like the services. One particular thing about I want to talk about in AWS is like, the services um, are not available on all of the regions, okay, because they actually make the service available only if the customer demands. Okay, if the customer demand is there in that particular region, then only they will provision the services. Otherwise they won't pre-provision the services in these particular edge locations. But with Azure, it's not like that. They try as much as making these particular services available all of the regions, so that they can get to the market, get to the customers before others go. And then with the GCP, and with the GCP is the same thing. It's they are trying and they are growing their business. They are growing their numbers and or their presence in a lot of different places. And if you take an example of, let's go to Microsoft Azure, then it has a good integration, very good integration with, since AWS is used by most of the open source guys who are, open source developers who are more developing solutions across open source technologies. But again, this game is getting changed after, Microsoft has pitched into more, like it says, Microsoft love open source. So it started its particular presence of into open source, like after the acquisition of GitHub repository. And now with the GitHub repository, they are offering something called as, if you use a open source or your own private repository, you do not need to pay for the build minutes if you're building a code on Azure DevOps pipeline with the GitHub private repo. Okay, that's one of the good offerings which I can say that like it's Microsoft is trying to be more inclined towards open source. But yes, if you're not agreeing, please put in the comment why don't you agree. And then there's something called as, well, like it has a broad feature set. Yeah, like Amazon, what they are good in it, like they make different versions of different products, a single specific unique service. So similar to that, Azure is also doing. And they have a concept of hybrid cloud. They have a concept of Azure Stack. So Azure Stack is running your own Azure in your on-premise. If you have a requirement like you do not want to expose your services, or you do not want your particular calls going out of your particular data center, then you have an Azure Stack, which this particular software you can take all the leverage of advantage of Azure, which has to offer on cloud, except scaling and other thing, because that would depend upon your on-premise. And it has also an offering called as hybrid cloud, where um, you can have your set of half of the infrastructure on your on-premise and half of the infrastructure on cloud. It's same with AWS also has the same offering for you, so where you can make your particular resources part of VPC on cloud and other resources in your VPN. And then like support for open source, yes, it's open now. And then if you go to GCP, you have yes, the GCP being like has more commitment to open source, and the portability is also very good, because if you take an example of the Kubernetes or containers, with the solution which they have developed is really great, because and they're thinking their development, everything is across open source. So obviously that GCP is the best, which I can say for all of the developers who are developing solutions on open source, using open source tools. And yes, since it's niche, so the discounts are also bigger, and the flexible contracts, like you're not binded to for an enterprise agreement with of using their particular services. And yes, DevOps expertise would be there, because they are the people who actually bought the concept of DevOps, the concept of site reliability engineering and everything. Okay, so weaknesses which let me put it down is like, Amazon AWS is difficult to use because, if you're infra guy, you will have an understanding how exactly the pieces works behind. Okay, it's not very user friendly, I would say. The console is a bit difficult to understand. It's not so easy if we compare with the Microsoft Azure. Okay, and AWS service, yeah, the cost management is not great because they have now started developing, they have their own particular internal tool of cost management, but still there were at times there were issues which the vendors or customers used to have. And overwhelming options, yes, there are overwhelming options for many of the service offerings which is there because we will talk about those particular services because that's going to be a huge list. And with Azure, it's gonna be, the documentation is less, but they are improving on it, they're ramping up on it. And incomplete management tooling, yes, this is there, but again they have acquired few of the few of solutions, like Cloudin is one particular solution which actually are more of management tooling across, how across any of the cloud vendors or on Azure. So you can use Cloudin for it. So, but yes, they are also, they are incomplete and they are ramping up. And then if you take up an example of GCP, then they started with, because GCP is sort of developer centric company, I can say. Like, they have new ideas, innovations, they build softwares, they do not build machines. Okay, and but they have entered into IaaS markets, hope they would make a good difference in the market. And obviously the features are less and services are less compared to AWS and Azure, but hopefully they gonna make it. Historically, yes, the GCP offering is new to the market, and it never had an enterprise share uh, till now, and they need to focus on the enterprise right now. Okay, so with this, I hope you would have understood the brief differences between among AWS, Azure, and GCP. Hope you like it, and if you do not like it, let me know why you do not like it, and then put up your thoughts in the comment section, and keep following the Azure guy. Peace.